Welcome to my channel SKSN Chemistry Coaching. Myself Khaseem Shaik, Chemistry faculty. This is my first video. If you like this video, please do subscribe and press the bell icon so that you will get my videos continuously as notifications. The first topic I am taking is ionization of weak acids from the chapter equilibrium. Right, students, acids based on the strength, they can be classified into two types. Acids based on the strength classified into two types: strong acids and weak acids. Strong acids are the acids which undergo complete ionization in aqueous medium, right? On the other hand, we have weak acids which attains the equilibrium with its ions, right? For example, if you take HCl, when we put HCl in water, it will ionize completely to give H plus ion and Cl minus. We can write it as 100% ionization takes place. Right? For the strong acid, there is no molecular form exists, only ionic form exists. Okay. On the other hand, weak acid, when we put a weak acid like acetic acid in water, which will attain the equilibrium with its ions, CH3COO minus plus H plus, acetate ion plus and hydrogen ion it will use. For the weak acid in aqueous medium, both molecular as well as ionic form will exist, right? So, how to memorize, how to know whether the given acid is strong or weak? That is, it is very easy. You can memorize these list of 6 acids: perchloric acid, hydroiodic, hydrobromic, sulfuric, hydrochloric, nitric acid. These 6 acids we can consider as a strong acids. Other than these 6, we have to consider as a weak acids, right? So strong acids are acids which ionizes 100% in water. No molecular form will exist. They are called as strong acids. Weak acids, for weak acids in the aqueous medium, both will exist. Molecules as well as an ionic form will exist. Right? So let us enter into the topic: ionization of weak acids. Ionization of weak acids. Students, let us consider the concentration of weak acid. The concentration of weak acid as C and degree of dissociation as alpha. Degree of dissociation as alpha, right? Let us take acid, weak acid general formula HA. When we put a weak acid in water, it will attain the equilibrium with its ions. HA is not any particular acid, it is a general formula of a weak acid which gives H plus and A minus ions, right? Let us consider the initial concentrations. Initially, there is only acid HA is present. Its concentration is C, and H plus and A minus concentrations are 0, 0. Before ionization, we are considering only acid HA is present. At equilibrium condition, when we are assuming degree of dissociation as alpha, at equilibrium conditions, the concentration of acid is C minus C alpha, because out of the C concentration, C alpha is dissociated. We are assuming the degree of dissociation as alpha. then H plus ion concentration will be C alpha, and A minus also it is a C alpha. When C alpha concentration of weak acid is ionization, undergoing ionization, it will give us the same amount of H plus and A minus. C alpha as well as A minus also it is a C alpha, right? Let us write the equilibrium constant for this reaction. Acid ionization constant, we can represent it as a Ka. That is active mass of the products, product of active mass of the products raised to the power of its stoichiometric quotients, H plus power 1 and A minus concentration power 1 divided by concentration of Ha power 1. Let us substitute the concentration values in terms of the C alpha. That is C alpha into C alpha divided by Ha. The acid concentration at equilibrium is C into 1 minus alpha. From the term C minus C alpha, we are taking C as a common, then 1 minus alpha will get, right? So 1 C will get cancelled. Here generally for the weak acids, alpha is very much lesser than 1. So 1 minus alpha is approximately equal to 1, right? Then Ka is equal to C into alpha square by 1. So which is C into alpha square, Ka is equal to, right? So then if you transfer C to the opposite side of the equation, alpha square is equal to Ka by C, right? Then alpha is equal to degree of dissociation, alpha is equal to square root of Ka by C. Students, from this equation it is clear that the concentration C and the degree of dissociation both are inversely proportional to each other. That means as the C decreases, concentration decreases, alpha increases. As the C increases, alpha decreases, right? So we can write it as concentration is decreasing. When the concentration decreasing means dilution increases. Dilution increases, then degree of dissociation, alpha increases. As the concentration decreases, dilution increases, degree of dissociation, alpha increases, which is known as Ostwald dilution law, which is known as Ostwald's dilution law. Ostwald dilution law. Students, next we will derive the formula to calculate the pH for the weak acid. pH calculation. pH calculation. pH calculation. We will take ionization equation of HA, which gives H plus plus A minus. Initial concentration is C. For H plus is 0, A minus also it is 0. At equilibrium condition, concentration of HA is C minus C alpha. H plus is also, it is a C alpha, A minus is C alpha, right? Then to calculate the pH, we require H plus ion concentration, because pH is equal to minus log of H plus, right? Then from this H plus ion concentration is C alpha. Okay, let us substitute that. pH is equal to minus log of H plus ion concentration is C alpha, C into alpha, right? Earlier we have derived that alpha value is equal to square root of Ka by C. So minus log of C into alpha value is the square root of Ka by C. This C we can write it as root C into root C. So this one root C and root C will get cancelled. So we are getting it as minus log square root of root A into root B. We can write it as root of AB, right? This again we can write it as minus log of C into K square root. If it is there, we can write it as whole power 1 by 2, right? So this is in the form of log A power m. We can write it as m log A. M place we have 1 by 2. So minus 1 by 2 log C into K. This again we can expand by using the formula log of AB, log A plus log B. So pH is equal to minus half into from this. This is in the form of log of AB. A place we have C and B place we have K. So minus 1 by 2 into log C plus log K, right? So multiply this minus inside, we will get a pH is equal to 1 by 2 into, this is minus log C, minus into plus is minus, minus log C, minus into plus is minus log K, right? So minus log Ka we can write it as a pK, minus log Ka is equal to pK, minus log H plus is equal to pH, minus log OH minus is equal to pOH. Similarly minus log Ka is equal to pK. So pH is equal to half into minus log Ka, I am writing first, that is pKa minus log C. This is a formula used for calculating the pH of weak acid, right? Let us do one question based on this. Question is calculate the pH of 0.01 molar acetic acid, which is aqueous acetic acid solution, and the pK of acetic acid is given as 4.76, right? Students, we can use the same formula. pH is equal to 1 by 2 into pKa minus log C, right? Which is half into pK is 4.76, it is given, minus log concentration is given as C is equal to 0.01, which can be written as 10 power minus 2 molar, right? Minus log 10 power minus 2. So half into 4.76. This is log A power m. We can write it as m log A. So minus of minus 2 into log 10 base 10, which is equal to 1. So 1 by 2 into 4.76, minus into minus is plus 2, log 10 base 10 is 1, so 1 multiplied by 2 is 2 only will get. So 1 by 2 into 4.76 plus 2 is 6.76. Okay, simplified, 2 1s are 2 3s are 6, 2 3s are 6, 1 will remain 16, it will becomes 2 8s are 16. So pH value is 3.38. Students, let us solve one more question. The question is equal volumes of two acidic solutions with pH 2 comma 3 are mixed together, then the pH of resulting solution is right. Students, pH for two solutions given, solution 1, solution 2, these are mixed together in equal volumes. Let us assume that volume of the first solution is V, then volume of the second solution also is V, because both are equal volumes it is present, right? So pH for the first solution is 10 power, we can write pH is equal to 2. So pH is minus log of H plus is equal to 2. Similarly for the second solution, pH is equal to 3 minus log of H plus is equal to 3, right? So from this we can write H plus is equal to 10 power minus 2, because here base is 10. Similarly for this we can write H plus is equal to 10 power minus 3, right? So to calculate the pH of resulting solution, we need to calculate the H plus ion concentration in the resulting solution. So for that we can use the molarity formula for mixing. M3V3 is equal to M1V1 plus M2V2, right? So M3 is a H plus ion concentration in the resulting solution. V3, when we are adding the volume V and volume V2 solutions, volume will become as total volume is 2V is equal to M1 is 10 power minus 2, the concentration of H plus in the first solution, multiplied by volume V1 is equal to V and V2 also equal to V. So 10 power minus 2 into V plus M2 value is 10 power minus 3 into V, right? So here we can take a V as a common, so V and this V will get cancelled. So H plus ion concentration is equal to 10 power minus 2 plus 10 power minus 3 by 2. If you transfer 2 to the other side of the equation. So we got H plus ion concentration. To calculate the pH, we need to take minus log on both sides. By taking inverse logarithm on both sides, left hand side we will get a minus log H plus is equal to minus log 10 power minus 2 plus 10 power minus 3 by 2. Students, this is in the form of log of A by B. We can write this minus log H plus as pH is equal to minus this minus of log 10 power minus 2 will take common from the numerator, then 1 plus 10 power minus 1, right? This 2 we can write it as minus log 2, right? Log A by B, log of A by B we can write it as log A minus log B, right? Then pH is equal to minus log of 10 power minus 2 into this is, we can write this as approximately 1, right? So 1 plus 10 power minus 1 is 0.1, so which is approximately 1. So minus into minus is plus log 2. Minus log of 10 power minus 2 is minus of minus 2 into log 10 plus log 2. Minus of minus is plus 2 into log 10 base 10 is 1. So 2 into 1 plus log 2 value is 0.3. So final pH we get it as a 2.3, right? Students, no need to do all these calculations. When the pH, both the solutions, if they are given as equal volumes and acidic solutions are there, then resulting solution pH is lower pH plus 0.3. Similarly, for example, if it is given as two equal volumes of two solutions with the pH 4,5 are mixed together, then resulting solution pH will be lower pH, that is 4 plus 0.3 is equal to 4.3. Whereas for the alkaline solutions, resulting solution pH is, when they are mixed in equal volumes, solution pH is equal to higher pH plus 0.3, that is higher pH minus 0.3, right? So if it is 8, 9 are given, higher pH is 9 minus 0.3, which is equal to 8 minus 7, right? So students, this is the first topic I have taken. If you like this video, please do subscribe. Thanks for watching.